Welcome back, everyone, to the NITEX Colloquium series. Today, unfortunately, Professor Petriccione couldn't make it, so he asked me to present the speaker. I apologize for the little delay we had due to technical issues. I'm not going to delay it further. Let me say just very briefly about the speaker a few words. You already seen his biography on the Colloquium advert. Dr. Mochegwa is the inaugural director of the African Open Science Platform, AOSP, with a strategic portfolio to direct and support the AOSP. He has a PhD in computer science from City, University of London, UK, at the School of Mathematics, Computer Science and Engineering. And he'll be talking to us today about a very important topic, African Open Science Platform towards a continental open science vision. We look forward to your talk.
Okay, so hopefully it's, can you hear me at the back? I'm delighted to be here. And this is not the first time in Stellenbosch. First time I came, I think it's 2013, Rene. There was an exciting project to set up technology transfer offices in the Southern African countries. And we so happened to engage with advanced, mature TTOs in South Africa. I remember visiting Anita Nell, is she still here? Heading Enovas here in Stellenbosch. And we subsequently also worked on another very exciting project, still under the same theme of really developing structures and capacity in the innovation ecosystems. Then we were looking to strengthen university, industry, government co-creation platforms. We engaged with the Launch Lab. And I think that's an exciting project because you do know that us as universities, including Stellenbosch, we have an obligation, I think, to upskill our students to make sure that in addition to the very, very good academic training we give them, we also prepare them for industry. And I think Stellenbosch has been very, very progressive over the years in that regard. And we subsequently had also another project to strengthen resilience of innovation ecosystems. And I was doing this at University of Botswana Department of Computer Science. And I think these linkages are very important, which is why I'm also very, very excited to be back here and with your organization. I'm coming today wearing a different hat because I'm the incoming director for a very exciting project. And I think I'm convinced I'm going to have the best job in the world. Because this gives us an opportunity, a tantalizing opportunity to develop a Pan-African platform that will see us collaborating across board, including on working on projects that are of continental importance. So I hope some of the audience here and online, we have early career researchers, PhD students, and we've got master students who are the future of this continent. So briefly, you'll see in the subsequent slides that there are a number of facets to this very, very important but challenging problem. The issue of having appropriate policy frameworks at national level, at the regional level, even institutionally, at Stellenbosch, what do you have in terms of policies to support this vision within your own organization? Do we have the appropriate infrastructure to allow our scientists to do research right here in Stellenbosch or right here in South Africa, enabled by appropriate infrastructure? Or do we have a dispensation whereby African researchers still have to try to beg for infrastructure access outside the world, outside the continent? The issue of data across multiple disciplines is critical. Where is the data that we produce through our scientific endeavors? Is it in Professor X's laptop, waiting for him to go back to his country with it, while he's been funded by X government for years? Or is it the obligation of the university to ensure that there is sufficient provisions and infrastructure to allow him to be able to deposit and share research outputs, including data, in such a manner that it can be used and utilized at the very minimum for reproducibility of work. Very important. The issue of access to scientific literature, access to knowledge, very critical. We do know that it's very, very expensive to access scientific literature. What about the issues of equity? How do we ensure that all of us can equitably access scientific literature? The skills for scientists to do science in the 21st century, for scientists and students who are going to become scientists to be trained to do science in this new dispensation. I think it's important. More importantly, I would argue, is are we configured at our institutions with the right incentives to perpetuate the behaviors that allow us to be open in doing science? Very, very critical, because it just goes to emphasize that there will be a natural tension between what is required of the scientists and what the scientists themselves perceive is the right path to progression. This must be handled through incentives. And of course, the last two, we need to think about how we are collaborating, not only within the university, but also nationally and also continentally. And of course, the issue of the necessary partnerships that we need to have. Industry is increasingly important as a funder of research. We have the necessary partnerships to do this. So really, I just wanted to show you through that slide the very core issues that the African Open Science Platform will be trying to address. Okay. I will show this picture. For me, I think it's profound. It challenges my knowledge of geography. I don't know how many of you can picture the scale of this continent. Certainly, I wasn't aware that we can fit most of the world in here, apart from obviously Eurasia. Huge. That gives us the sense of the challenges and opportunities in trying to do what I've just said, coordinate activities, enhance collaboration, but also shows us the potential that the continent has. And I wanted to showcase the scale of the continent through my own experiences. I was here for the Synergy Summit, 16th to the 22nd in Stellenbosch. I had an opportunity to visit some of the vineyards. I saw people tasting some wines. I was driving, so I really couldn't. But it's critical to see that the ecosystem that you have here in Stellenbosch, the wine industry, the farming, can also leverage, obviously, technology and science to advance it. And indeed, it has, which is very, very admirable. And indeed, Rene, the summit, the Synergy Summit that you hosted, showcased some very good use cases for how high-performance computing could be used to solve some challenges. You remember there was even a gentleman from FNB talking about the use of HPC in corporate risk management. I think this is also very important. When I left Stellenbosch on the 22nd, I then went to Abidjan in Cote d'Ivoire. Picturesque, as you can see. I didn't know Abidjan was this big. I think from what I look at, probably the size of Joburg or bigger. They got, I think, the second biggest port, maybe after Durban. And they've got all these resorts. And you go down the other side of the town, you see the other side of Africa. Vigorous activity, motivated entrepreneurs, people eking out a living in markets. But you see the potential. And you see the potential of using science and technology to elevate livelihoods. How can they, for example, increase production in terms of the agricultural produce? How can they, for example, with the vast knowledge, indigenous knowledge that they have, bring it into the mainstream so that their products and knowledge can be an asset to the world? For me, I see potential. And a day or two later, I got a flight to go to Morocco. Maybe before then, let me tell you that I was in Abidjan because there was a Space Sciences Conference. Very important, given the challenges that I've just talked about. Is there a way of using space sciences in this case to address socio-economic transformation? We all know of the use of satellites for use cases such as Earth observation and the image analysis, the data science, the computational infrastructure that is required to do that. Can we focus our science to be able to address the challenges that I've just shown you? For me, I think it was critical. This conference brought together scientists, academia, in this case, brought together policymakers, ministers were there. It also brought together industry. There were colleagues from Stellenbosch who were working on CubeSat satellites who were first met there. And I think it's important. The governments of different African countries were presenting on their space science strategies and how they are implementing them, the partnerships they're making, and the ecosystems they're developing around space sciences. And I think this is important. There were obviously a number of companies from around the world who are obviously looking to partner and engage these governments. For me, this is important because it contextualizes how, at an African level, through, for example, in this case, the development of an African space agency, which is meant to coordinate in the continent space science activities and the accompanying African space science strategy to be able to enact all this. Angola, for example, in the Southern African region, have made significant investment in satellite technologies, looking to provide leadership and obviously strategic leadership as far as they are concerned in the space sciences in the region. And I was saying after that event, precisely 2 days after the event, I went to Morocco because I wanted to go and engage on a very, very critical aspect of what I'm going to talk about. What are the infrastructure provisions in the continent to allow us to do data and compute intensive science? I learned a few things. That the oldest university in the world is in Morocco, not Cambridge, not Oxford, but in Morocco. 1857, 1859. And the Moroccans are very keen to showcase that going forward in the continent, they want to build universities that can attract African scientists to come and engage in their universities. I visited a town called Begueria. It's a university town and is facilitated by a mining company called OCP. You'll see later that Morocco is the world's largest resource of phosphates. The fertilizers that you probably use in South Africa, some of them come from OCP. They've got the largest footprint in terms of phosphates. Long, long time ago, the whole of Sahara was under the sea. As difficult as it sounds, thence the sedimentary rocks rich in phosphates. I'm showing there how Morocco is trying to transform itself into this agricultural landscape through technology and exploiting this resource to not only build towns, but to build university. That's a master plan of the University Mohammed VI in Begueria. I met the man who said he built this thing from scratch himself. Very humble man. And in addition to this, they installed and procured the fastest supercomputer in Africa at 3.15 petaflops for those who follow the trends in terms of the benchmarks for HPC. You know, there's a top 500 list through which you can see the investment in HPC. Not only are they doing that, they are looking to advance in various areas that are computational intensive. They are also looking to train in the relevant areas. I'm saying this because there are students here who may not even know these opportunities. There are researchers here who may not even know these opportunities. It's very important at a continental level to know these pockets of excellence and investment so that these future scientists, when they make collaborations, know where to go. Indeed, colleagues, I thought I'll spend some time there. I know this is 1 hour, but I wanted to provide a context because the AOSP, one of the key things is exactly this, the coordination of activities and sharing of information regarding opportunities. This is also another slide that shows how Africa has a vision to solve its own problems that we all know, multifaceted, and cannot be tackled by a singular country. But at a continental level, we do have the policies. This is the science and technology policy for Africa. It's under revision. This is up to 2024. It highlights key strategic areas for the continent that can be addressed through science. Remember, the science that we do must not only address obviously scientific endeavors, but primarily the challenges of the continent. I'm also showcasing here another very important instrument, the African Digital Transformation Strategy, that talks of all the good things that we know are critical. And then, of course, it's also about livelihoods. The governments that fund our research, at the end of the day, they want to improve livelihoods for their own people. So this is critical. And colleagues, all these things you are talking about require us to have a scientific ecosystem that is efficient, transparent, vibrant, but also that engages the society in which it's embedded. And I've alluded to the thing on the right. We also need to think about, is our science accessible, not only to other scientists, but also to society? If you are a scientist doing public health, collecting data about patients or collecting data about the population, and you go write a paper, is there a way for your findings to propagate back to society? Is that embedded in your project? So really, this issue of democratizing science is critical, and we know that this is a particular challenge for the continent. Colleagues, you are at university, you know the challenge with access to scientific publications. Staggering. 70% of all scientific publications are behind paywalls. I write a paper, he reviews it, we pay the journal to publish. Stellenbosch pays the journal to access my paper so that she can do a literature review. There's something wrong with the setup. And then, of course, on the right-hand side, you see also, again, the figures were very good for COVID. Remember what happened with COVID? There was an impetus to share scientific work freely, and that provided a precedent. But still, look, 50% of all publications regarding climate change, something that we know is important, are behind paywalls. It means only universities that can afford to pay for these things can progress. Colleagues, I just want to make sure that I run through this because I think it's a bigger picture that we need to appreciate. It's not about me as a professor progressing. It's about the system we are building and whether it's fit for purpose going forward right here in Africa or in Europe or elsewhere in the world. What do we need to do? We can see that it's very, very critical that we think about timely access to scientific data. What's the point of using data today and only it being accessible 20 years from now? Very important for us to think about how can we provide this timely data sets. Scientific collaborations is important. And of course, we know the issues in our scientific enterprise regarding the access to technology and of course, gender gaps. How many women are in this talk, at least in this room? I'm sure Renee and my colleague there from Cameroon, yes? Maybe a few others. These things are very important in our scientific enterprise. I've got this diagram, which I think is also very important. Scientific collaborations in the world is fairly old, but I'm sure there's new data. You can see at the top there how collaborations evolved in Europe and the US. Of course, the denser the graph, the more collaborations you have. You can see it's very sparse. It's a sparse graph in the continent. We need to do more. Question is, am I collaborating enough with her professor in Cameroon? Am I collaborating more with my professor in Dresden in Germany? What can we do to enhance intra-African collaborations? You can see that it's got better for South Africa, presumably because some investments you made, maybe through NRF, through infrastructure and all these things. We need certain interventions to do this. So really, I just wanted to highlight those precursor areas. There's the issue of science and technology diplomacy, trying to address those issues. Can we use scientific, technological, and academic collaborations among countries to try to distort what I've just shown? In fact, in some countries, these infrastructures can be used as a way of diplomacy. Countries that are otherwise at war, working together on a particle physics collider, maybe at CERN or maybe in the Middle East. So it's very, very important for us to think about these things. I also want to share this diagram because I think it talks to everything I talked about. We all know that not everybody could do a Morocco. Not everybody could do a South Africa with your CHPC. But if we create an ecosystem where we share some of these very expensive investments through some modalities, through some connectivity, it's very critical because it will allow us all of a sudden to have this collective environment we can work in. Can we also make sure that we know who's an expert in what? I don't even have a clue. Who are the experts in material science in the university I just came from in Morocco? I'm very, very sure that they probably don't even know who are the experts in material science in Stellenbosch, if at all they want to go for joint funding with some funder somewhere. Some of the expensive instruments, of course, they are domain specific. If you look at those doing chemistry or physics or material science, electronic equipment that are used, very expensive. The telescopes, some people are doing astronomy here, very expensive. And then, of course, the issue of data. How do we then, if we have such an ecosystem, share data sets, work on problems together? So really, I'm emphasizing there this notion of a cyber infrastructure. Is it not only these things, but also the human capital to make the most use of it? In most cases, also because you are working in this ecosystem, you can actually go into very sound agreements with third-party providers of services because you've got collective bargaining, isn't it? If you are a library in a consortium of these universities, you can actually go for cheaper, better rates for the things that you access. I was in Brno in Czech Republic late last year in October at the ICRI conference, the International Conference of Research Infrastructure. Very nice declaration came out of it. Understanding what I've just said. Very important, not only nationally, regionally, but globally, for us to at least look at the possibilities of having our research infrastructures collaborate. Africa, for example, is a continent that has got very few mature research infrastructure. Think about it. You're trying to do a climate model. You need observations from all over the continent. If you have a dark continent with no sensors, how good are your models going to be? So the issue of collaborating continentally is also of critical importance. Colleagues, I came here because Francesco and the colleagues who I met last time wanted me to give a little talk on open science because everybody's talking about open science. Students are also curious about it. What is it? It's exactly what I've highlighted there. A number of pillars, open access to research literature. As a computer scientist, I can relate to this. In the late 1980s, a young computer scientist called Linus Torvalds took a teaching operating system of Professor Teinbaum and created a small kernel that could now run on the x86 and created a community of altruistic software developers who gave out their code for free. And guess what? Today, our data centers at industries and banks are running Linux. There are some business models on top of freeness, isn't it? So why is knowledge not free? MIT introduced open courseware. You can get access to the best materials by the best professors who wrote all those books. Not that he's not the best, not that I'm not the best, but we can provide knowledge for free. The same argument goes here. Can we provide access to literature in a way that reflects maybe the realistic cost of what it takes to publish? Who pays what and why are we paying a lot more? The issue of data is central, is the elephant in the room. Can we make the data as open as possible? Not to open up everything. There is some sensitive data sets that you cannot open up, but where possible, especially research data that is probably even emanating from research funded by governments, for example. Can it be made open as possible and closed as necessary with some conditions? You see that there's now talk beyond openness, but more towards fair data, data that we can find. These are the important attributes. Is there a way we can find this data in terms of using standard protocols, in terms of describing it with metadata, et cetera, et cetera? The findability of data, the data that is accessible, data sets that talk to each other, that are interoperable. The health outcomes are related to environmental data, to other data sets, isn't it? So data must talk to each other. And more importantly, data that is reusable. So that's the second pillar of open science, the openness of data. Because we recognize that data is an important output of research. Not only the professor's publication is important in terms of him being cited, but the data sets that he produced and the workflows that he used to produce the data. Remember, science is all about reproducibility. Why are we writing the publication only but not sharing the data and the process that led to the data? So open science is questioning these things and say, look, data is an important aspect of research output. Let's do something about it. Really, this is about the open culture and methodology of open discussion and inquiry, including, like I said, share those Python scripts. Get your research software engineers to write software that can be readable and used by others. Do share those images, Docker images that you have, things like this. So, colleagues, and then the last point there, the science that we do must engage society, because society and they are important stakeholder, and we must have obviously sufficient interfaces for that. So really, if I were to share a slide about what open science is, this will be it in terms of summary. And of course, the motivations of why open science. If somebody's asking you, why do you open science? For starters, is good scientific practice to communicate evidence. Why are you holding on to the evidence? What are you hiding? Just publish a PhD dissertation. Why are you afraid to put your data sets for scrutiny? The same with the scripts that you use to generate those very nice images, very important. And of course, open data has transformed a lot of areas. The astronomers know this very well. People in genomics know this very well. And of course, the last point there, that indeed, we can obviously accelerate scientific discovery through the reuse of data. I also share this in case somebody asks you further, again, why do open science? You can see some very vivid, simple illustrations. It's efficient. Working on the same data together is more efficient than reproducing it singularly in different projects. You can get more research from the same data. Nobody can argue with that. Public disclosure. It's very important to promote access, like I said, in terms of the public use. Economic benefits. So really, this is a slide that also highlights why we need to do open science. Colleagues, this is where the world is going. If we can do all this at an institutional level, at the national level, and then migrate to doing this at the regional level as Southern African countries, and then at a continental level, as I'm going to talk about today, and then at a global level, we can actually have a global open science platform that allows us to collaborate on those projects we do not need to compete in. We know the problems: climate change, disaster risk management, SDGs. So it's a very noble thing to work towards. And indeed, other continents are making progress. For those who are from Europe, you'll be aware of the European Open Science Cloud and what they're trying to do there. Colleagues, I wanted also, because it's a colloquium, to give you information. There has been a discussion at a multilateral level, at the UN level, to provide some recommendations about open science. And these were not plugged from the air. They were done through consultations with your governments, with institutions, with many stakeholders. And they provide a basis for a common understanding of what open science is in terms of what I just illustrated. And countries are encouraged to embrace these recommendations and implement them. In that spirit, embrace the culture and practice of open science with the benefits that we talked about. And they've also encouraged countries to report every 3 years along the lines of obviously measurable metrics regarding open science. And of course, in terms of what the recommendations themselves are, is the first international normative instruments on open science. A definition was agreed that puts society at the core. And obviously the recommendation spells out this consensus around the core values. And of course, all those things that you see there. So I really strongly encourage organizations, researchers, students, and policymakers to look at these recommendations because of the areas that I talked about. You'll also see in the UNESCO documentation the different areas or the key pillars of open science. I want to draw attention to the pillar on a dialogue with other knowledge systems. This is pertinent to Africa. We do have, obviously, vast amounts of knowledge that is not in the mainstream science. How is mainstream science engaging these knowledge owners to bring this to the fore? And we know the challenges that has been coming up because of limitations in doing this. Of course, the issue of open scientific knowledge, we talked about it. The issue of open infrastructures, we talked about it. And of course, making sure that we do not forget the public when we engage in science. And I also wanted also to share the slides with yourselves for informational purposes. And you see what countries are encouraged to do. Member states are encouraged to prioritize the areas that you see there. Starting, for example, with making sure that you all appreciate what open science is. We create a policy environment. We have the necessary infrastructure. We train our scientists in these areas. We also promote the necessary cultures, et cetera, et cetera. And we also endeavor to engage in scientific collaborations. Colleagues, also for informational purposes, if we do this, what are the key impact areas? You'll agree that if we do what the recommendations say, we'll change the scientific culture at universities. Are we perpetuating the right culture by this publish or perish anecdote, in which case we know the games that have been played? Who benefits, the scientists or society? Are we training? Are we having right infrastructure, et cetera, et cetera? And then, colleagues, UNESCO has developed a toolkit that will help guide and operationalize some of these things. So if you're a dean or a vice chancellor or a funding agency or a national institute, there are some guidelines that you can glean from this UNESCO toolkit. And there are some specific recommendations to universities that you as Stellenbosch can look at. There it is, colleagues. I don't know about Stellenbosch, but we know the challenges at universities. Are we configured appropriately for what I've just said? What about the criteria of evaluating scientific excellence? As a professor, do I need to be standing here talking about open science, or should I be busy in my lab doing experiments and writing my next paper? Does the university recognize that what you do to perpetuate this? Because in the reward system, this is not a scientific output. Very important, because it starts with perpetuating the right behaviors. Of course, issues of quality. And we know quality has a price, yeah? Garbage in, garbage out. And of course, there are opportunities if we do it right. And of course, the role of governments clearly laid out. Adopt the recommendations, ensure their implementation, invest in open infrastructures, and invest in open science, colleagues. If we do all this, utopia, we can gain a lot more. We know that the African continent is young. If we change the way we do science and teach our young scientists the future, there's still time to do it. I know that you cannot teach an old dog new tricks, but at least we can do something there. We know data is hidden in governments. Originally, I'm from Botswana. Botswana is the largest exporter of diamonds in the world for over 50 years. We have a geological survey that has got data sets about processing, about prospecting for minerals. I'm sure the same in South Africa. If I'm an investor coming into a country X with these data sets and I want to do the prospecting for the next mine, where do I get that data set to be able to home in maybe on areas that has been prospected? And of course, we know other areas where open science can be of value. Africa itself has seen it necessary to call for an implementation of the international framework of open science. I was in Rwanda 2021, where they were 2022. You can see the key declaration. One of the messages coming out was that we must look as Africa to implement this. We must increase access of early career researchers to be able to publish even in indigenous languages. I was talking to my colleague here about ChatGPT. ChatGPT is a large language model. It becomes better with training. If you do not have Afrikaans literature in the internet, chances are that you've got less training data sets, let alone Shona or Zulu or Setswana, isn't it? So we must publish more and make available more information through indigenous languages. So this is critical, colleagues, to the continent. I was building up to this. Sorry, maybe I had taken too long. I was motivating why we need an African open science platform to stimulate this interactivity and to develop efficiencies of scale, create the critical masses. Maybe you've got 10 professors here working in area X. They can do so much. But imagine you've got 1,000 coordinated and collaborating in the continent. They can do more, amplifying impact and sharing those capacities. The Moroccan machine, the South African machine, somehow coordinated or connected to allow all African researchers to access it, and a commonality of purpose and voice. I often get invited in international fora to say, what is the position of Africa on this? I cannot represent Africa, but I can get African voices in some platforms where these things are discussed, which is what the platform aims to do. And of course, if we are configured properly, we can engage in joint action with the rest of the world. Colleagues, without taking too long, these are things that AOSP seeks to do. We want to make sure that we implement those recommendations. We also want to make sure that we showcase African research, of which there's a lot, but it's not visible. And we also, more importantly, to create the linkages that we all know are lucky because of the vastness of the continent. All this is not utopia, is not something that we want to have as a pipe dream. We want to take a pragmatic approach, start somewhere, and then grow this thing. And as a basis for this, a landscape study was done to really say who is doing what in the continent in terms of capacities, in terms of activities. And that landscape study is available. In fact, one of the things that will be done is to enhance it, given that this was in 2018. And colleagues, a strategy was developed that I want you to appreciate because it's also relevant to Stellenbosch and to the network that I know NITEX has. The issues, I've already mentioned them. Can we have access to infrastructure federated? I should be able to log in into a computational platform from wherever I am as an African scientist and be able to run my computational chemistry experiments, simulations, yes? With some modalities. We should be able to have soft provisions for things like policies. And we talked about research data management. Data curation. How do you take data, collect data, steward it, curate it such that it becomes fair? There's a process, isn't it? How do we do that? And we have got aspirations as a continent to have this data science and AI institute, probably engaging universities and institutes that have got a mandate for this, or got competencies in this. And this can be accessible in the continent, through which data sets that are made available can be accessed. Today, I don't know where to find some data sets in my domain. I have to go to the internet and do things, isn't it? And of course, colleagues, this is it here. Could we come up with projects? We've got projects that are addressing challenges that could be of continental footprint. The continent needs to know about it. And how do they know about it? We need to have a platform that provides visibility of the work that we do. And I mentioned these two networks here. Training, if we are doing training in Stellenbosch through NITEC, why is it not visible to somebody in Ghana? Because we just agreed that it's quite critical to open up training, for example. It benefits all the students. AIMS, for example, could be doing training for its network. Why is it not available in Kenya? That training, isn't it? So you're doing fantastic work, Renee and NITEC, in terms of broadcasting some of this colloquium, for example. You will be a part of this network of education and skills. And of course, this necessary network of open access and engaging with society to give us those problems that we know that society wants. Colleagues, very, very quickly, all this is in a strategy. The strategy is available publicly, and these are the different areas the strategy will address in terms of implementation. You'd agree that governance issues are critical. I'll show you later that there's a governing council that will provide oversight into some of these things. I'll also, you'll also see here that thinking about what I just said, what is the impact of open science? How do we measure impact? So the notion of having a monitoring and evaluation framework is very important. And of course, all these different activities that we talked about. Colleagues, if you ask me, who are the potential partners for ASP? Stakeholders. There they are. And we know that we have these groups in the continent. The users themselves, the community of practice, the different domains, the community of practice, bioinformatics, so genomics, astronomers, physicists, biologists, conservationists. These are communities of practice. They're important stakeholders. And of course, the African Community of Support, the African Association of Universities, Science Councils, and the like. So really, in terms of mapping out why ASP is relevant and its value proposition, it was very, very important to really think about who are the stakeholders. I'm also sharing with you there. Maybe as a university, think about why would you want to be part of ASP? There is a value proposition to that end. Colleagues, in terms of implementation, this is going to be a hub and spoke model where the coordinating hub is based at NRF because DSI submitted a strong proposal to the continent to host it there as a coordinating hub. But there will be different nodes, as you can see, in the different regions, appreciating the diversity and the scale of the continent. These nodes will be able to push for implementation of various aspects of ASP, and then there will be cross-fertilization of outcomes through the whole network. And then, of course, this is what we hope the nodes themselves will provide in terms of value, without boring you too much with the details. Colleagues, in terms of what has been done to date, the coordinating hub is up and running at NRF. There's a gap analysis to update the information that I showed you, the landscape study. There's a lot of positioning that has been done to showcase, at least to do what we are doing today, that ASP is here, this is what it's trying to do across the different areas that we talked about. We in the process of establishing regional nodes, a governing council is up and running. There's also synergious networks like the Science Granting Council network in the continent. ASP will have to work closely with such networks in terms of resource mobilization. And there's a lot of good activity in the continent across areas of policy, open access, and training. ASP is looking already to coagulate and coordinate some of those activities. Colleagues, very, very quickly, remember, science must address societal problems. Question is, how does Professor X come up with a proposal for a project without looking at what the policy landscapes and priorities for South Africa are, or for Kenya are, or for the region are? So it's very, very important to engage governments and regional bodies regarding their strategies and policies. I'm giving an example here of SADC. At a regional level, these countries are talking about integrating across different areas, including science and technology. There's a lot of policy and strategies along those lines. I'm giving an example of the work that we did in SADC, trying to motivate development of that cyber infrastructure I talked about. That in developing it, we had to motivate how this is aligned with all this. Politicians want to hear this. Scientists somehow do not want to communicate this language, but I think it's critical so that when you come up with your project, you can show how it aligns, and then hopefully you can get investments for this government. I'm giving here one example of that cyber infrastructure project, the issue of access to computational infrastructure. I don't know about Stellenbosch, but a lot of universities in South Africa do not have HPCs. South Africa, fortunately, has got the CHPC, which is available in the country. But is that the case for Zimbabwe? Is that the case for Botswana? Is that the case for Malawi? Maybe not. At the universities themselves, we have budgets for infrastructure to provide these compute. So that's a very nice little project that looked to work with very large supercomputing facilities in America to then transport some of these compute nodes and install them. This is me in the computer science department in University of Botswana. Excited by the possibility of this one rack has created a large community of computational chemists, computational fluid dynamists. Some PhD students have graduated doing simulations in here. Some bioinformatics people are doing things that they couldn't otherwise do. So it's very critical to see that you can actually, on a small scale, at the university level, have an intervention that makes a difference. through relationships, in this case, with CHPC and the American counterparts, I had a picture of where, as a department, we shipped some of these racks at the departmental costs to the university to be able to do that. And then I've got a number of systems admin. This young lady here was a master's student. Guess what? She's now in the UK working for a consultancy company, because after she graduated, they poached her. And I've got a number of systems admins there who are also on the verge of leaving because of the skills they've gotten out of this little experiment. For me, I think it's critical. And of course, we've got partners like the ICTP, of whom you met last time. They're doing things, helping training of scientists, systems admin in the global south for the use of HPCs and data science. Again, this is the team that we took for ICTP as far back as 2015, I think, to engage. I'm showing this as an example that we can perpetuate now that we've done it in the Southern African countries across the continent. Remember, we're talking about universities. At the national level, maybe countries are looking at certain things. Colleagues, I talked about the problems, where the projects may come from. This is the Regional Indicative Strategic Plan for SADC for the next 7 years. It's got a number of pillars, a number of areas. I've just picked one here in terms of infrastructure development for meteorology. And the project that the Secretary General was saying in the next 7 years, what can we do? Stakeholders were there to look and unpack some of these projects. Academia should be here, talking the same language as policymakers. Colleagues, I also want to highlight areas where, as a continent, already we can use this project to perpetuate open science. You know the good work done through H3 Africa, for those who are into genomics, and the H3 Bionet in the continent. And indeed, there's a follow-on project funded by the NIH to develop an open data science platform and coordinating center. It's led by your compatriots here at UCT, but it's a coordinating center for the whole NIH DSI Africa project. Genomics, but where is the data? Where can we house it in the continent today? At the moment, they're using private clouds to do this. But long term, we'll argue that we need to host projects like this in the continent, colleagues. Space science is an exciting area. I just talked about what we were discussing in Cote d'Ivoire. There's a space science strategy for the continent. Countries got space science strategies. Here in South Africa, got SANSA, an exciting area. So I was talking to Digital Earth Africa. Big projects, arrangements with satellite data providers like Copernicus, sandboxes and workflows to train students in some of these processes. And you will argue that we can use space sciences as an avenue for doing collaboration in science. I'm also giving you another one. Remember, at the end of the day, it's also about society. This is Transfrontier Game Reserve, if you want to call it that spans a number of Southern African countries. These ones do not know borders, and they also interact with humans in sometimes unsafe ways. So we need technologies to be able to obviously manage conservation. And these are World Heritage Sites. This is the Okavango, for those of you who are into observation and conservation. Data sets in terms of related areas. Colleagues, maybe in wrapping, it's been a long lecture, if I will call it that, but I think it's important for students here and researchers to appreciate some of the activities that are happening regarding this area of open science. In October, there will be a conference for the NRENs. These are the National Education Research Networks in Kampala. You always have an open science session there. For those who want to write papers or abstracts or want to engage around open science, you may find relevant sessions there. The biggest conference in data, research data, is the International Data Week. The first one was in Denver in 2016. And I'm glad to say the second one was in the continent in Botswana in 2018. And South Africa has just won the bid to host the 2027 one, I think. But this year it's in Salzburg, in Austria. And right here in Stellenbosch, you are going to have the Open Repositories Conference. It's a community of libraries, community of those who are managing open repositories. We'll be discussing this. I'll be here maybe for the keynote, one of the sessions. And on scholarly publication, there's also a conference. I happen to be in the organizing committee for this conference. Colleagues, I wanted to share this so that you can maybe, if interested, look at the upcoming events in these areas. In summary, colleagues, open science is a key enabler for transforming our scientific enterprises. We have the guidelines from UNESCO that have got implications and advice at different levels. And we wish to perpetuate this in the countries and in the continent at large. And we all agree that Africa is very large in terms of scale, challenges, and opportunities. Coordination is important to also help pull together those areas of excellence that I've talked about. And of course, colleagues, we also want to make sure that African research is showcased. As we know very well, there is a lot of activity happening. Let me stop there, Rene, and give you the contacts, colleagues, of somebody you can inquire on everything that I've just said. That's the Deputy Director for the ASP based at NRF. And then there's a site right there. Thank you very much. How did I do for time, sir?
Thank you very much for your talk. Any questions from the audience here? And then we'll ask for questions online.
It's nice and cozy in here, so I think maybe I was very articulate enough.
Perhaps I could ask one question. So is there a plan to have a database of African researchers on that in your platform as a first step towards finding data? One could find a specific researcher working that field and then try to maybe...
I think so. I think these are all different systems that are important. That network we talked about, the network of training, for example, the network of open access, these resources that give us more information about what's happening in the continent is critical. We're going to have, for example, a database of institutions that are members of the platform. So indeed, this will be one of the key things that we want to provide to the world, to provide a mechanism for discoverability so that we can formulate some of these projects that we know could be done in the continent through collaboration. So really, that's one of the key things, yeah.
Thanks. Do we have any questions online? Maybe there is still one more question from the audience here. Would you like to go ahead, sir?
You gave an example of what could be achieved with what Linus Torvalds achieved when he created Linux.
Yeah.
So from that perspective, I suppose there's a few questions that could be made. So Linux, while it is huge in some ways, in others, it only has a 2% market share in the worldwide usage, however, of operating systems. However, from a professional perspective, it has a 47% market share. So I guess a few ways you could take a question like that. What do you think is possible as far as a usage of an open science platform, and from like what sort of audience maybe? Or even so, we all know Linux, it has the problem of that it has a huge and steep learning curve. And when you encounter problems, you're often on your own and trying to fix them. So if there are sort of Achilles heels to an open science platform, what do you think would be ones that need to be mitigated, or ones that maybe would be prevalent in usage of such a platform?
Oh, these are important conversations. Remember, when I gave the example of Linux, I was giving an example of an open culture that created something that then benefited the world. The internet is based on this openness I'm talking about. And I was saying that on top of the open culture and products that come of it, there could be business models that allow those that want to make money. I'm not sure about your statistic in terms of the Linux in general. I think on the desktop, maybe. Yeah, on the desktop. I mean, you're right. Yeah. That's right. I mean, on the desktop. But if you look at what is powering things like the internet, data centers, yeah, one would argue, if you look at the top 500 supercomputers in the world, probably 80, 90% are on Linux. So I wouldn't want to dwell too much on the statistics, but I wanted to dwell more on the fact that openness provides us with a sustainability mechanism that allows and encourages appropriate behaviors that in the long term will also benefit everybody. It's not the case that if you open up something, you don't benefit. You can have a business model on top of openness. And I also wanted to translate that into things like open access to scientific literature and how that could be of benefit to everybody. I can also argue with hardware as well, open hardware. why do we have proprietary hardware design, even for adapters? Why could we not have open standards that everybody designs against the standards to provide things that are interoperability? Now, you are right. There's obviously benefits and pros and cons to everything. The issue of opening up data and the issue of different levels of advance in different scientific ecosystems. South African ecosystem maybe is more advanced than the Zimbabwean one or the Botswana one. South African ecosystem is less advanced than the American one. So opening up things also requires you maybe to have that advancement in your ecosystem so they can collaborate properly, isn't it? So really you can analyze these disadvantages, but I was also wanting to make sure that at least we appreciate that diagram there gives you a good value proposition. Somebody asks you, why do you open science? You can actually code those, but I do concur. People tend to think there's also a tension between intellectual property and opening up things. Remember what IP says. If you're at the University of Stellenbosch, you come up with a scientific discovery, your Office of Research can work with you to advise you on how to explore the commercialization of your work, in which case the investor invests maybe millions of rands to file a patent. And what happens when you file a patent? You have to divulge in great detail all the work that is involved in developing what you are developing. And then, of course, if this passes the originality test, the international system gives you protection for 20 years so that you and you only can accrue benefit from your discovery or your invention. After 20 years, this thing reverts back to the public domain, in which case everybody can use it. So really, there's a provision where your university can obviously analyze the value of what you're doing commercially. But there's also a provision that where research is publicly funded, is of public good, you make it available as soon as you can, isn't it? Notwithstanding that you have to publish. So really, you are right. There are some cons, but I would argue, and I'm sure you'd argue too, the benefits of opening these things up are more critical than the cons. Thanks for the question.
Thank you very much. We did reach the end of our time. I will just read two questions from the online participants, and please just a very short answer to the second question. The first one is just a remark which says that there is already the SF African Scientist Directory. So this is Academy of Sciences of South Africa.
There you go.
And then there is a question: can universities outside of South Africa be a part of the open science platform?
Definitely. So I like that remark. Remember, ASAF, the Academy of South Africa, Sciences of South Africa, did the pilot study on ASP. They have a directory. What are the other directories out there? And how can they be, for example, connected so that you got a global directory? So these things are possibilities through ASP to make sure that these things are also accessible to the outside world. So indeed, that's a good remark.
So let's thank the speaker again. Thank you very much for your very interesting talk.